Welcome to Margin of Error. In the last video, we talked about what a confidence interval was and how to find it using a margin of error. But in this video, we're specifically going to focus on questions that revolve around the margin of error as opposed to the entire confidence interval. So start working on the do now, pause the video, resume the video when you're ready to see the answer. So this question is asking for which interval reflects 95% of the critical reading scores. Now they're talking about an interval that has 95%. That tells me we're talking about the confidence interval. We know that to find the confidence interval from the last video, you're going to take your mean or sample proportion, but this particular problem is talking about the mean, and we are going to add and subtract your margin of error. Now, you might notice that this question doesn't talk about a margin of error at all. So in order to find the margin of error, we need twice the standard deviation. So really, I can rewrite this as the mean plus or minus 2 times your standard deviation. Now, a big question that I usually get with this problem is, what does the word respectively mean? All that means is that you go in order that everything was listed in. For example, the mean score came first, so it would be the first number in the list. The modal score came second, so it is the second number. And the standard deviation that came third is going to be the third number. Now, within those numbers, we know the mean, we know the standard deviation. We have not worked with the modal score at all yet. So it's safe to say that we can just cross this out. And it doesn't really have anything to do with this problem. It's just additional information. So now we have the mean, which is 496, and twice the standard deviation. The standard deviation is 115. If we simplify that, we get 496 plus or minus 2 times 115 is 230. Oops, nope, not that one. This one, choice 4. Just be careful because you can see that 115 was an answer choice. They were hoping that you would forget to multiply it by 2. So let's talk about some of the vocab. If you were to run an experiment on a sample of, let's say, people, and your findings from this experiment is going to result in either a sample mean or a sample proportion, depending on what you're looking at. Let's talk about sample mean. From there, you're going to take that information and run a simulation. What the simulation is going to do is provide a more detailed and accurate understanding of what you can expect. And the simulation allows us to come up with a margin of error. I like to think about the margin of error as some wiggle room. Let's say my period 1 class had an average of an 87 on a test. I don't expect my entire average, as in all of my students combined from my other periods, to have an average of exactly an 87 on this test. But I can expect them to get somewhere close to an 87, right? So I'm going to find a range for what I expect them to get on a test using the margin of error. So we go up by the margin of error, and we go down by the margin of error. And then that allows us to get a range. And this range is called your confidence interval. And we were 95% sure that the population average of my test grades is going to fall somewhere between this interval. So now, last week, we talked about finding the confidence interval given the margin of error. We're going to turn it around a bit. We're going to be finding the margin of error given the confidence interval this time. Now, there are multiple ways to do this, and if you prefer a different way and you find that it works, great. However, I'm going to be doing it this way each time. So what we're going to do first is we're going to break it up into 2 steps. The first step is going to be to find the sample proportion or the sample mean. Now notice I have decimals all less than 1 here, so I know that I'm working with proportions. So in order to find the average, you're going to take 0.35 plus 0.65, divide it by 2, and I'm going to get 0.5. Now that means this is my sample proportion. Because remember, in the confidence interval, your sample proportion or sample mean is directly in the center of it. Now that you have your sample proportion, we can find the margin of error. And that's going to be, take the upper bound of your confidence interval and subtract the sample proportion. Overall, we're going to get 0.15 as your margin of error. If you're having a little trouble understanding what's happening, we have our confidence interval. We're finding the average of the confidence interval, right? The number directly in the middle to find the sample proportion. Now, remember that your margin of error is the distance from the sample proportion to the edge of your confidence interval. So I'm going to take the upper bound, right, this value over here, and subtract it from the sample proportion to find that distance and that margin of error. Let's try another example. I'm going to find the average first. And when I do that, I'm going to get that my sample proportion is 0.75. From there, I'm going to take my upper bound of the confidence interval, and I'm going to subtract my sample proportion that I just found. And I should be getting that my answer is 0.03 as my margin of error. Now, again, I did mention there are other ways to solve this. The reason why I like this way is because it also finds your sample proportion, which sometimes the questions also ask for. So this one finds both pieces of information, and you don't have to go back to find anything else. Parts C and D are going to be part of your assignment later. Now, again, we have similar type of question. They want us to find the margin of error. However, this time notice that we're not working with decimals that are less than 1. So I know we're talking about means. Also because the question is saying means instead of proportion, that helps. So it's done the same exact way. You're going to find your average. You should be getting 17. Now, keep in mind that we're talking about means, so I'm going to write that this is your sample mean x bar. From there, you take the upper bound and subtract the sample mean, and you get that 2 is your margin of error. You could try the next one on your own and resume the video when you're done. Keep in mind for the next one, it's not x bar in the middle, it's mu, because we're saying the population mean is somewhere in this confidence interval. In order to find x bar, the sample mean, you need to find the average, the number directly in the middle of these two numbers. Not step 2, we're starting with step 1. So here we have 172 plus 178 over 2. We're going to get the sample mean is 175 as your x bar. Step 2, take the upper limit, subtract your sample mean, and you should be getting 3 as your margin of error. Choice, part C and D are going to be for your assignment as well. Now, sometimes they don't give you the confidence interval, and yet they still want you to find the margin of error. So it's going to take some estimation. The first thing you should do is label where p hat or x bar is going to be on your graph. Now, if you read this question, we're saying his staff received responses from 900 likely voters, and 55% of them said that they would vote for the candidate. The staff then conducted a simulation of 1,000 more polls of 900 voters, assuming that 55% of the voters would vote for the candidate. So this whole thing is being based around 55%, which means your p hat is going to be 0.55. We're turning the percentage into a decimal. So I'm going to go to my graph, and I'm going to label 0.55 as my p hat. Now, you have to estimate about 95% of the data where it's centered around this p hat. So my estimations would maybe be between here and here. That's about 95% of the graph to me. From there, you're going to calculate what the margin of error is. Now that's about 0.03, right? From 0.55 to 0.58, about 0.03. And if you look at the answer choices, that actually happens to be there. Now, if you have some trouble estimating it this way, you can do something else. You can actually look at the options they give you and create a confidence interval for each one. So let me just scroll down a bit. We know that your confidence interval is p hat plus or minus your margin of error. So I'm going to go, I'm going to go one by one. I have 0.55 plus or minus option 1, which is 0.01. If I do that, that's going to get me to 0.54 to 0.56. Now I'm going to go and look at the graph. And I'm going to go from 0.54 to 0.56. Does that look like 95% of the graph to you? And I would say, no, it's too small. Which means that can't be an option. So you're going to move on to the next one. The next one is 0.03. So 0.55 plus or minus 0.03. That's going to get me a confidence interval of 0.52 to 0.58. And I'm going to go up to my graph and look, 0.52 to 0.58 is that area in between 95% of the data. Now, you might say yes or no, you might be unsure. Keep in mind that it doesn't seem overly large. It also doesn't seem overly small. It's a candidate for the possible correct answer. So we're not going to cross that one out. We're going to go on to the next one, 0.06. Oops, sorry. We have 0.55 plus or minus 0.06. That's what I meant to write. Now that's going to bring you to 0.49 to 0.61. Go to the graph, 0.49 is here, 0.61 is there. Is that 95% of the data? To me, that's 100% of the data. So this one is too large. And we're going to cross that off from being a possible answer. And then you're going to try the very last one too. Now, the very last one is a number even larger than that. So if you were thinking things through, you can say, well, if 0.06 was too large, then 0.12 is definitely going to be too large. But let's see what actually happens if you do it out. That's going to bring you to 0.43 to 0.67. Those numbers aren't even on the graph. So if I go from here to here and I count everything in between, that's a little, it's a lot much. It's definitely way too large. So usually with these questions, the nice thing is if you were to go and look at each and every option, one will be reasonable and the others will definitely either be way too large or way too small. So there are your two ways of doing it. Let's look at another question. We have some smartphone applications contain in-app purchases, which allow users to purchase special content within the application. A random sample of 140 users found that 35% of in-app purchase 35% made in-app purchases. A simulation was conducted with 200 samples of 140 users, assuming 35% of samples make in-app purchases, and the approximately normal results are shown below. That is a mouthful. They want you to consider the middle 95% of the data, so using the confidence interval, they want you to determine the margin of error to the nearest hundredth for the simulated results. Now, they're telling you simulated results. That automatically means this, in which case we don't really have to go back to the first paragraph of the problem. So in order to find your margin of error, we know that your margin of error is twice the standard deviation. In this case, my standard deviation up here is 0.042. So the margin of error you should be getting is 0.084. Now this problem does say to round to the nearest hundredth. There's a lot to be cautious about when reading statistic problems. So the answer to the margin of error should be 0.08. From there, they want you to explain what the value represents in given context. Now, think about it this way. What do we use the margin of errors to help us find? And the answer to that is we use it to help us find the 95% confidence interval. The problem is even saying consider the middle 95% of the data. So we can use this margin of error to figure out the confidence interval. We're going to start with your sample proportion. Oops. We're going to use, there we go. We're going to use the mean, right? So we have 0.35 plus or minus the margin of error. And you should be getting a confidence interval of 0.27 to 0.43. And now we can actually write a description. So a margin of error of 0.08 means what? Now it means that we can expect that 27 to 43% of the users will make in-app purchases. That's what our confidence interval said. Keep in mind, I specifically wrote we can expect that. I didn't say that 27 to 43% of users will definitely make in-app purchases. Remember, this is only 95% sure that this is happening. So you always want to write, this is what we can expect to happen, not that this is exactly what will happen. So keep in mind when you're doing these problems, you want to actually read, are they asking you for the margin of error or are they asking you for the confidence interval? You don't want to provide an answer with the wrong information of what they're asking for. And that's all for this video.